Surface area of pyramids. We're on lesson 7 of chapter 8. And this lesson is, I would say, a bit more challenging than the prisms lesson where we found surface area of prisms. One key part of this lesson is that we agree on some vocab. All right, so there's some kind of new vocab, new-ish vocab here about pyramids. Let's focus here on lateral area. Well, first we have to talk about what is a lateral surface. Lateral surface are the non-base faces. All right, all the faces that aren't bases, or we call them lateral faces or lateral surfaces. All right, so all these triangles around here that go up to that apex there, they're the lateral surfaces. So lateral area is just find the area of each of these triangles and add them up, and that gives you the total lateral area. Now there's this formula that we're going to go over and practice that gives us the lateral area. It's kind of weird. We're not used to having a capital P and a cursive L. But they're capital and cursive for a specific reason, because they want to indicate to you a specific thing to find. And right here, it lists it. All right. What is the big P? The big P is the perimeter of the base. All right. The perimeter of the base is the capital P. So perimeter, remember, is adding up all the side lengths, the distance around the outer edge of a shape. So you can see I'm tracing with the pointer this outer length. So we would calculate the length of that, or the perimeter of the base, and then we'd multiply it by this cursive L, which represents slant height. So that's another vocab word that we have to be aware of. Slant height is the height of the triangles, the height of the actual triangles that make up these lateral faces. It's not the height of the pyramid, which we are used to. It's not that height that goes from the center of the base up to the apex. Okay, it's not that height. That's a different height. Now that meets the base at a right angle, but the slant height is actually the height of the triangular faces. All right, the triangular faces. So we can use this formula to find that lateral area. All right, and to get the total surface area, we're simply going to find the area of the base and add it to the area of all the other triangular sides, the lateral area. So the area of the base, right here, surface area of a pyramid is the area of the base plus the lateral surface area. Another way to write that is this here. All right, so you're going to have to practice using this formula. All right, using this formula where big B, just like it was for our volume formulas, is the area of the base. Then we're going to add to it half of big P, capital P, which means the perimeter of the base, and then multiply it by the slant height. All right, so it's going to take some practice, but I think you'll be capable of doing it. Now, you can also just find the surface area of a pyramid by finding the individual areas of each face and adding them up, just like we did in prisms, just like you can do with any three-dimensional figure. If you can find the area of each face and add them, you can find the surface area. All right, so let's move on. Let's do some practice. All right, now the good thing to remember is that these are regular pyramids. That means the bases, all right, the bases are regular polygons, which means they have, they're basically perfect polygons. All right, all the side lengths are the same and all the angles are the same. So they're the perfect polygon. Anyway, so this formula only works for those types of pyramids, the ones with a regular base. All right. And then where are we? Then you can see that this can unfold to this. You could find the area of each of these 5 polygons and add them up. All right. You can see, or you can use that formula that we talked about previously, and then we can see that these are all the slant heights here of the triangle. So the slant height is just the height of the triangular faces of the polygon. I mean, of the pyramid. All right. So here's just another explanation, and you can read through that. Let's get some practice going. All right, example 1. So it's always good to identify the shape. All right, identify the shape. It looks like a pyramid, and then identify the base of that pyramid. So base of the pyramid, here we have, oops, we have a square. Not drawing nicely for me. All right, we have a square. So we need to know the base. We need to know what shape it is. So since we're finding the surface area of a pyramid and it's a regular pyramid, we can use the formula that we talked about on the first page. And they've written it here. This is how I want you to show your work as well. Now, big B stands for what? It stands for the area of the base. So you can see that over here, they took care of big B right there. They found the area of that square base. And when we find the area of a base, we just do length times width, or base times height. So that's 4 times 4, and that's how they showed that. All right, now we need to find P. All right, and what's that stand for? The perimeter of the base. Now, this might be confusing. Why is that also 4 times 4? That's confusing. Really, what they should have done is 4, and you would probably want to write this in so that when you go back and study, you're not confused. 4 plus 4 plus 4, right? Because perimeter, we're adding up the side lengths. It just happened to be that there are 4 4s, so that's also 4 times 4, but I don't want you to get confused that the perimeter is just going to be, multiplication, just doing like the dimensions times each other. No, it's not. It's whatever the dimensions are, adding them up to get all the way around the shape to get the perimeter. All right. So we found the big B, we found big P. Now we need the cursive L, which stands for the slant height. So that's the slant height going up there. Now, there could be a moment where some diabolical math teacher tries to confuse you, and they throw this in just to mess with you, and they give it another number. Let's say they give you, I got to turn on my do not disturb. Where is that? There we go. All right, we're good to go now. All right. Anyway, so where was I? Okay, yeah, some diabolical, evil math teacher will throw that in and label that, I don't know, it looks like, let's say it's 8. All right, and you won't even use that at all for this whole problem, but they'll throw it in there just to throw you off, confuse you, distract you. But you're going to know, oh wait, I don't need the height of the pyramid in this case. I only need the slant height when I'm finding surface area. All right, so that's a big hint, clue, tip in case someone's trying to throw you off. All right, let's go to the next one. And really, it's just using this formula and knowing that you have to find the big B and the big P off to the side and then plug them in. All right. A triangular pyramid. So let's indicate the base here. The base is a triangle. All right, the base is a triangle. I'm going to clear that out. I'm upset by this problem. I'm upset by this problem because, oh, no, I'm not. This is another one of those tricks where I fell for it. But then I'm like, wait, this doesn't seem right. Why is this a problem? Okay, I was looking at this base and I don't see, right? I'm looking at this base. I don't see a right angle down there on the base. I see the right angle for the slant height, but I don't see a right angle there. I'm like, no, they have to show me a right angle because I need to find the base and height of that to find the area. Then, whoa, math teacher, hello, read the directions. Find the total surface area of the pyramid with a base area of 111 square meters. So they already gave me the base area. They already gave me big B. All right, I don't have to calculate that. Okay, so I can erase this. Let me clear all this. Let's see if the eraser is actually working now. No, it's not. Okay, so I'm going to clear it all out. Okay. Anyway, so we already got big B. That's going to be 111. All right, we can just replace it because it tells you that right there. And then we have to find the big P, which is the perimeter of the base. And so you know all three side lengths are 16. So the perimeter equals 16 plus 16 plus 16. All right. And then the slant height we know is the height of the lateral surface here, this triangle. So that would be 20. So we plug all those in, calculate, and get that answer. All right. Now we have one last example before our got it's. We see that this is a triangular pyramid. I'm going to read the directions this time. Find the total surface area of the pyramid. All right. So they didn't give us the big B in this case, so we're going to have to find it. And luckily, I see that the base here tells me everything I need to know. All right. I see a right angle on the base. So now when I am finding the area of the base, I know that it's a triangular base. So I need a different formula than what I used up here for the area of the base, right? I had an area of a square there, which would just be one dimension times the other dimension, base times height. But since I'm doing a triangular base, I need 1/2 base times height of that triangle. And so I see that my base is 10, my height is 8.7. I substitute it in here into my area formula, and I get 43.5. Now, I also need capital P, which is the perimeter of the base. Perimeter is the outside edges all added up. So 10 plus 10 plus 10 gives me a perimeter of the base of 30. My slant height, wow, all these numbers. What's the slant height? Slant height is the height of a lateral face. So that's that guy going up there, which is 12. It takes some focus. It takes paying attention to details, but plug it in and there's your answer there. All right, I'm going to have you try these, pause it, try these, and then I'll show you the work. So pause. Try it yourself. Let's see how we do. All right, I'm going to show the work over to the left on the screen here. This is going to be A. All right. So A, I'm going to read carefully. Find the surface area of a square pyramid. I know that the big B, the base of the pyramid, is a square that has a slant height of 8 centimeters and a base length of 5 centimeters. Now, if you like drawing, you could draw yourself a square kind of slanted, and you can draw in the the other parts of it. We know that the slant height is going to be 5, and the sides of the base, since it's a square, let's see. Oops, no, the slant height is 8. My bad. Is that right? Oh, and the sides of the base length is 5. So that's going to be 5 by 5. All right, so let's write down that formula. Surface area equals big B plus 1/2 capital P cursive L. Now, we're going to find surface area, we need to first find B. So capital B, the base of this pyramid is a square. So we're simply going to do 5 times 5 and get 25 plus 1/2. Now we have to find capital P, which is the perimeter of the base. So that's 5, 5, 5, and 5. So 5 plus 5 plus 5 plus 5, which gives me 20. So that's going to be 20. And my slant height, it said, was 8. All right, ready to calculate. It's 25 plus half of 20 is 10. 10 times 8 is 80. So that gives me a surface area of 105. And since we're doing area, it's going to be units squared. So let's see, centimeters squared. All right, let's try part B. I'm used to doing that big B now. Capital B, here we go. Let's read it carefully. Find the surface area of the pyramid shown. All right, so total surface area. So surface area of a pyramid is capital B plus 1/2 the perimeter of the base times the slant height. You should have this written down somewhere, like maybe make a formula sheet for chapter 8 yourself of all the things that you want to remember. Or you can use the one that I posted on Google Classroom. But we first have to find big B, which is the area of the base. So I'm going to go over to this. I'm going to outline my base so I don't get confused. All right, that's a triangular base. So I'm going to do 1/2 times base times height. What's the base and height of that triangle? Looks like what meets at a right angle? It looks like 12 times 10.4. All right, need some help there. So let's go find 12 times 10.4 times my half, which I'll just use 0.5, and that's 62.4. All right, so 62.4 plus 1/2. The perimeter, what's the perimeter now of the base? It looks like I have around the outside, I have 12, 12, 12. 12 plus 12 plus 12, or 12 times 3 gives me 36. And my my slant height, which is the height of the lateral surfaces here, is 15. All right, what do we got here? Okay, half of 36 would be 18. So 18 times 15. 18 times 15, 270. And then we're going to add to it. What are we adding to it? Oopsie. Adding to it 62.4. So 62.4. 332.4. 332.4. And the surface area is always square units, so meters squared. Let's see if I got them right. Oh, yeah. I think so, right? Yep. Oh, yeah. Good stuff. And I'll turn this off so on our next page, you won't get a heads up. All right, hopefully you did well. If not, try to figure out where you might have gone wrong. And if you're still having trouble, then email me. Okay, let's see how we do here. Sal is wrapping gift boxes that are square pyramids for party favors. They have a slant height of 3 inches and base edges of 2.5 inches long. How many square inches of cardstock are used to make one gift box? Notice there's no mention of surface area in this problem. So how do you know that you're not finding volume? How do you know you're going to find surface area? Okay. Well, you have to understand that they're trying to basically fold cardstock. That's like a piece of paper that's thicker and stronger, cardstock, to make one gift box. So it's like you're doing a net, right? So you're taking a flat surface and folding it up to make a three-dimensional figure. So that's your indication that we're doing area in this case. right? Because we're measuring how much of something that's flat, how much of something that's two-dimensional do we need. All right, so that's how you know it's going to be a surface area problem. And then it's just like the previous problems that we've talked about, where you have to use the formula and then calculate B, calculate P, find cursive L, and plug it in and calculate. Okay, good luck. Hopefully you can follow that formula. Also, a backup plan, find the area of all the surfaces and add them up. Yeah, you can do that with any shape. You can do that with any shape, any three-dimensional shape where you have the appropriate dimensions given to you. All right. Good luck with this lesson. Hopefully it's not too confusing. Let me know if it is.